Here's something that'll blow your mind. A painting worth millions of dollars just had one of its biggest secrets cracked wide open using nothing but lasers and molecular detective work. We're talking about Jackson Pollock's masterpiece, Number 1A, 1948. That iconic canvas where paint seems to dance across nearly 9 feet of pure artistic chaos. For decades, art experts and scientists have been stumped by one burning question. What exactly created that mesmerizing turquoise blue that practically jumps off the canvas? But here's where it gets fascinating and a little controversial. While most people see Pollock's work as random splatters and drips, scientists have just proven there's nothing random about the chemistry behind his colors. Using cutting-edge laser technology, researchers finally identified the mysterious blue as manganese blue. A synthetic pigment that's as vibrant as it is problematic. Let me break this down for you in simple terms. The research team, working with samples from the Museum of Modern Art in New York, used a technique that sounds like science fiction. They fired lasers at tiny paint scrapings and measured how the molecules literally vibrated in response. Think of it like giving each color its own unique fingerprint that scientists can read and identify. This discovery, published in the prestigious Proceedings of the National Academy of Sciences, marks the first time anyone has definitively proven Pollock used this specific pigment. Edward Solomon from Stanford University, one of the study's co-authors, put it perfectly. It's really interesting to understand where some striking color comes from on a molecular level, and this is the part most people miss. Manganese blue isn't just any ordinary paint. This synthetic wonder was the go-to choice for artists who wanted that perfect turquoise pop. And it was even used to color swimming pool cement back in the day. But here's the kicker. By the 1990s, environmental concerns forced manufacturers to phase it out completely. So Pollock was working with a pigment that would eventually be banned. What makes this research even more intriguing is how the scientists approached their work. They discovered striking parallels between their methodical analysis and Pollock's own systematic technique. Abed Haddad, an assistant conservation scientist at MoMA and co-author of the study, noted, "I actually see a lot of similarities between the way that we worked and the way that Jackson Pollock worked on the painting." This challenges a common misconception about Pollock's art. While many viewers see chaotic randomness, Pollock himself firmly rejected that interpretation. He viewed his process as deliberate and controlled, much like these scientists who carefully analyzed every molecular vibration to solve their colorful mystery. The researchers had a unique advantage in studying Pollock's work compared to other artists. Since Pollock famously poured paint directly onto his canvases rather than mixing colors on a traditional palette first, scientists can take more precise samples and trace exactly which pigments he used where. It's like having a chemical roadmap of his creative process. The study authors described the artwork as a quintessential example of his action painting technique, where ropes of color, drips of black, and pools of white coalesce into the layered dynamism that defines his style. But they went beyond just identification. They dug deeper into the pigment's chemical structure to understand exactly how it produces such an eye-catching shade. This type of scientific art analysis serves multiple crucial purposes in today's art world. Conservation experts use chemical fingerprinting to preserve priceless works for future generations, while authentication specialists rely on these techniques to catch sophisticated forgeries that could fool even experienced art dealers. Speaking of authentication, Pollock's works have been turning up in the most unexpected places recently. Just 2 years ago in 2023, Bulgarian authorities seized what they believed to be a previously unknown Pollock during a police raid. Even more surprising, back in 2017, someone discovered what appeared to be a genuine Pollock painting gathering dust in an Arizona garage, potentially worth a staggering $15 million. But here's where things get controversial. If scientists can now definitively identify the exact pigments and techniques Pollock used, does this somehow diminish the mystique and emotional impact of his art? Are we reducing pure artistic expression to mere chemical formulas and molecular structures? Some art purists might argue that dissecting a masterpiece with lasers strips away its soul and reduces it to nothing more than a collection of synthetic compounds. Others contend that understanding the science behind the art actually enhances our appreciation and helps us better preserve these cultural treasures. What do you think? Does knowing that Pollock's stunning blue comes from a now-banned swimming pool pigment make his work more fascinating or somehow less magical? Should we be using high-tech molecular analysis to unlock the secrets of artistic masterpieces, or are some mysteries better left unsolved? I'm genuinely curious about your perspective. Does scientific analysis enhance your appreciation of art, or does it take away from the emotional experience? Let me know in the comments whether you're team science enhances art or team some mysteries should stay mysterious.